This is Cable Gobbler, but his friends call him Gobby. Gobby is a great robot vacuum, but has a nasty habit of eating cables and getting all tangled up when you're not looking. So me and my friend had the idea, what if we could teach Gobby that eating cables is wrong by giving it a pair of eyes, a way to steer itself, and an AI sentience to make decisions. And this weekend, that's exactly what me and my friend Joe set out to do. And, well... Ooh! Stuck?
Yeah.
No! But let's not get ahead of ourselves. Let's start from the beginning. So without any modifications, this is what happens to Gobby. He moves forward, he eats the cable, and then he gets tangled up and stops. So usually if Gobby wants to avoid something, he has a bumper and a bunch of infrared sensors on the front. And what that means is that if he bumps into anything, or if he detects something nearby, then he'll change direction. In this case, the cables are so low to the ground that neither of these functions trigger. So the natural solution to this is, well, let's just give him vision in that case. What we're gonna do is we're gonna tape a webcam to Gobby, we're gonna plug that into a computer, and then boom, vision. We don't have a small computer like a Raspberry Pi, so we're actually just gonna plug it into my laptop and then balance my laptop on top of Gobby. Let's now give Gobby the ability to change its direction on demand. This is going to be slightly less straightforward because we can't actually get into Gobby's hardware or software. So what we can do though is that we can artificially trigger his existing sensors to trick him into changing direction. So first we need to figure out where are his infrared sensors.
So if I come here and I go, yeah, yep.
Check this out. Okay. But... This is awesome. I feel like we're deciphering this thing. Yes. So now that we know where our IR sensors are, we can actually trigger them whenever we want just by putting something in front of them. And in this case, we're going to be using blinds on the end of something called a servo motor.
This is the servo motor. Yeah,
so what are we going to do with this? How many of these do we have?
We have one big one. Yeah, if we can imagine, you know, this is our intelligent robot. And, the idea is we just glue this on, or tape it on, because I don't want to
I think we're going to have to tape it on.
Yeah, don't worry, we're going to tape it. You literally just have a piece of cardboard and it just... I mean, so if we just have something bent like that, go on, right? Yeah, we need a long piece of cardboard that will like... have this thing do kind of...
So you could actually turn Gobby left and right using one long bar with a servo right in the middle. As the bar tilts, it will trigger one sensor and not the other. The next step was to code this up, which was a lot more straightforward than we expected.
Okay, I'm uploading the code. Let's see what it does. I hope it doesn't break anything or explode.
Oh! Shall we attach an arm to it?
Yeah, sounds good. So we just attach this to the thing and see if it gets controlled, I guess?
I think so.
So.
This is so fucking jank.
Yeah. I turn it on.
Ooh! Okay, so what's the issue here?
It's 45 degrees.
Okay, so the thing's a bit too big.
Yeah.
And it's also not like secured at all. So we basically miscalculated. We actually had the angle set too high, and what that meant is that the blinder was touching the floor and then dislocating itself. So just with some clever tweaking and a bit of math, we managed to get that fixed pretty quick. And just like that, now we had a steerable Gobby.
Okay, go!
No, Joe! Ooh! Is this stuck? Did it get stuck?
Yeah. Oh.
The answer was yes. Yes, he was stuck. So the script we used was just a test. It just went from left to right every few seconds. However, it got stuck on the right. And the reason for that is because the motor burnt out. And that really sucked. Mostly because that was our only big motor. The servo's fried, but luckily Joe has like 7 other smaller ones.
Yeah, we have tiny boys.
We reckon what we're gonna do is rewrite the code and we'll plug it in and it's gonna fucking work. We're gonna get some dinner. Luckily for us, we could reuse a lot of the stuff we already wrote. However, since our motor's a lot smaller and a lot weaker, it meant that we couldn't use the big cardboard we originally had because it was too heavy. So instead we opted for something smaller, like a popsicle stick. What this meant though is that we could only trigger the front sensor, which made Gobby turn randomly left or right. So we couldn't really steer him anymore. But at this stage, we didn't really care. We just wanted him to avoid cables. And... It works! Bro, oh my goodness.
Look at how good that looks.
So much work. Look at it, it's beautiful. So now that we have our vision and our steering, we need to build in some kind of clever logic in the middle that basically asks, hey, is there a cable in my vision? If yes, trigger a direction change. To do the interpretation, we're going to be using an AI model called Blip2. And how it basically works is you give it an image and then you can ask questions about the image. The technicalities of how we set this up doesn't actually matter. All you need to know is that we're using an online service called Replicate to host our model, and we're sending it frames from our webcam feed every 2 seconds or so. And Replicate works. So now it can actually take input from the video and say whether there's a cable there or not. And now we have all our working bits together, and I present to you the new and improved Gobby. It's just like covered in cables.
It's all the smarts.
All that's left to do now is test out his new skills. 1:48 a.m., test 5.
We are go.
We are go.
No!
I think that's... Yay! Kind of. Did it eat it? No, it avoided it!
Yeah.
It avoided it! Bro, high five. Look at it freaking out. It's seeing cables everywhere. It's seeing cables everywhere, man. So obviously we were super psyched that it worked. But the day after we reviewed the footage from our camera feed, and it seems like he did actually touch the cable. He didn't react fast enough in time, but that's absolutely fine because he still detected it eventually and avoided it, which is fantastic. But here we go. Here's our final. Oops, shit. It's falling to bits. But like I'm genuinely surprised that we managed to like get this as a concept to work.
Yeah.
I didn't think it would work as well as it did, which is like, I think saying something.
Yeah.
You know what I mean?
I knew it was gonna work. There's no way. This is foolproof. Come on. Like. So yeah, I think we can say today we've learned that we fried a servo motor. Yes. I don't know why that happened. So,
we learned that we did fry one. We didn't know how or how to avoid it in the future. But
that's fine.
So I mean, obviously there's lots of things that could be improved and tweaked and optimized, etc., etc. But at this stage, we don't really care. It was a fun project. It was a proof of concept, and we got it to fundamentally work, which we're totally psyched about. And we're actually running low on battery now. It's going to turn off any moment. Final thoughts, Joe? Final thoughts?
Nice one. Good job.
Nice one,
so
dude.
Happy.
High five. Yeah! And now the battery. Hey there! Thank you so much for watching the video. I hope you enjoyed it. This is me a few weeks in the future after all the editing, etc. We want to get better at this. So while I was editing, there were lots of things I wish I did, lots of lessons learned around lighting and narrative, audio especially, and just generally how you might film things. Lots of things we wish we filmed, lots of things we filmed far too much of and couldn't use all of it or any of it. So it's an ongoing learning process. But if you do have any feedback, comments on what went well, what didn't come off very clear, what didn't look very nice, etc., absolutely let me know. Share it in the comments or send me a message. We just want to keep improving. We had a lot of fun doing this project, and we want to keep doing more fun projects in the future, but we also want to be able to tell the stories a bit better and more concisely, you know? So any feedback is absolutely welcome. Otherwise, thank you very much, and hope to see you again soon, and hopefully release something soon. God, who knows? Anyway, see you later.